This is Linux In-Laws, a podcast on free Libre open source software, broadcasting from the United Kingdom and Germany.
Welcome to Linux In-Laws, Season 2, Episode 37. Martin, how are things on this beautiful summer day in the year 2057? We're recording this on the 7th of June or something? Maybe I'm wrong?
Yeah, not too bad, apart from the calendar police being on my case again, as usual.
So how did you survive, actually, the kind of couple of world wars that happened in between when we founded the podcast and now? It's been a while, right?
This is the advantage of being on an island, right? It's quite hard to get.
I see. So I take it the flux capacitor is working once again?
Always, yep.
Excellent. But this is not a show about flux capacitors and time travel, but rather something about mobile technology and some other stuff, and of course, Python. And of course, we do have a guest. But Tobias, before we get even more wrong, why don't you introduce yourself?
Okay, of course. I'm Tobias Wegener. I studied chemistry, so I'm not like maybe the classical guy working in software. Then I did a PhD in fusion research and did some material science. And in this PhD, I did a lot of data analysis, and there I did it in Python. So that's how I came to software development. And now I'm working in chemical industries, and I do digitalization, so software development in the context of chemical industries.
Can I just interrupt you? You mentioned you studied fusion and ended up in software design. Is that a little bit?
Yes.
Well, let's say far removed, or are you finding that fulfilling enough?
I have a lot of side projects, I have to say. So the day job is cool. I have a lot of freedom, and I like software development. I do enjoy it quite much. But I also do some side projects, a startup in fusion research, and so on. So yeah, I know why you're asking. Let's say
you're doing fusion as a hobby instead of sound.
Martin, we found him.
Yeah. Well, he can help us with the flux capacitor as well.
Exactly. Keep talking, Tobias.
Sure. The problem is mostly the fuel, I think. So you need some tritium, which makes things more complicated.
But I mean, water is abundant on the planet, if I'm completely mistaken, no?
Yeah, general fuel is nearly limitless. But you need a certain kind of hydrogen, and this one is not so easy to get. Do you discuss this more?
You can fuse these atoms, no, in order to get tritium. Maybe I'm mistaken, I don't know.
No, it's like you normally use deuterium and tritium, and they are both hydrogen isotopes. So
exactly. I mean, tritium is a heavy water, no? As it's known in the trade.
It's part of... It can be part of heavy water, yes. So heavy water typically is deuterium oxygen. And then it could be one deuterium, one hydrogen, one oxygen, or it can be a tritium and a hydrogen, or two deuteriums. I think heavy water classically, in the way it's used in nuclear reactors, for example, in the CANDU reactors in Canada, they use D2 oxygen, so 2 times deuterium. But for fusion, you need another neutron, tritium. And tritium is radioactive and has a half-life time of 12.5 years. And there's, I think, about 3 kilograms all over the world. And it's costing about $1 billion. I think that's the English correct. So it's 10 to the power of 9 euros per kilogram. So it's very expensive. And when you want to have a working fusion reactor, you have to produce this in the process of making a fusion energy. You get the neutron, then you put it on a lithium, and then you split the lithium up into helium and tritium, and then you you refuel the reactor with deuterium and tritium. That was a sidebar.
Interesting. Martin, please do take note if this podcast thing finally blows, and I'm sure it will in a couple of years. Industry-grade production of tritium may be the way out.
Yeah.
Or the way forward, rather.
Sadly, I don't have any access to a reactor, but apart from that, it's all good.
Martin, but hang on, you're the theoretical physicist between the two of us, no? I thought you were.
No, I'm not. No.
Did I get that wrong? Okay, fair enough.
You did. Yeah.
Happens frequently.
I think Tobias is the one amongst us.
Especially at my age, anyway. Okay, yeah. But for the people who kind of tuned in late, this is not a show about theoretical physics, but rather about free and open source software. So, Tobias, why don't you tell us a little bit about the shenanigans with Python and mobile?
Yeah. So, as I said, I work in chemical industries, and there it's a relative conservative industry. So there's not a lot with cloud and stuff where we normally, today everybody uses cloud, but chemical industries are normally very conservative with their data, and they want to don't make public what they are doing at the moment, what they are producing at the moment, because it has influence of prices and stuff. So we normally are asked to develop for devices directly without cloud connection. And in this context, we had a problem with putting data together. People are running through a chemical plant and taking data in, and they do this still by paper a lot of the time. And there we wanted to have like a small solution which you can carry, and a mobile phone is like a natural choice for it. And other projects we mainly did in tk-enter and Python, so for desktop use. But then I saw from DLR a presentation that they promoted like the library Kiwi. It's an open source library for specifically all cross-platform use. And this we used for this project of putting numbers in a mobile way.
Before we go into the technical details, and yes, we do have about 4 hours on the podcast left, as in on this episode, maybe now is the time to take a step back and look at the general options you have at your disposal when you want to do something in the mobile space. And when I say mobile space, is to say primarily, I reckon I'm talking about Android now. Yeah. But of course, many frameworks are cross-platform. For example, Kotlin comes to mind with a multi-platform approach. But what alternatives did you look at before you decided to go the Python way?
None, actually.
Okay.
So we have like a software stack in Python. So we have a lot of libraries built up in Python. And then Kiwi was more a try in the context. So we saw, okay, there's a real Python library which can be used cross-platform. So we tried it with Kiwi. And from like a development efficiency, let's say it's very easy to get a working app in Kiwi. I think it's even easier than in tk-enter, which is relatively straightforward. It's a kind of a two-part language. You have like a designer language, where you can make like the mock-up with buttons and stuff. And these mock-up then is stored in a .kv file. And then you can call these kv IDs from the Python backend. And these can also be built up dynamically. And we have like an app where you want to go through different buildings and put in data for like meters, like counters, like for different media, like water, steam, electricity, something like this. And then we have like 15 buildings, and it's like 20 to 30 meters in each building. And in this case, we could just take like an Excel table, which with the people already had. As I said, it's pretty conservative. Then we can translate this Excel table into a JSON file. And then with this KV file, we can translate with Python the JSON file directly in the structure of the app. So it makes it very easy to the users to change the structure of the buildings or meters. Does that make sense?
It does, but I reckon before we kind of go into the debate, maybe now's the time to take a step back and to describe the general use case from a high-level perspective, so we can discuss the technical details later on.
Sure. You mean the general use case for this specific app we made, or?
I mean, exactly. I mean, I reckon if you mention TK Inter, of course, for the two people in the audience who are not familiar with Python, maybe three, I don't know, there is a couple of approaches to building graphical user interface in Python. TK Inter is the default standard one that is used in... Sorry?
Shall I tell some about? There's Qt, for example, which can be used alternatively for Python.
Exactly, but TK Inter is actually built into C Python as such, if you choose that distribution, so it's all good. But the point that I'm trying to make here is actually how, if you are looking at TK Inter as well, I reckon cross-platform was at one of the top positions of your requirements list when you set out to build the app, in terms of it had to run the desktop, it had to run a mobile, and you were just looking for a toolkit basically that would also cover mobile anger.
Yeah, it mostly should run on Android. That we don't have any iPhones in our
Okay, so just mobile, okay.
Yes, exactly. And the other parts of the project we did also in TK Inter, the desktop part. But to say it, Kiwi is absolutely, you can also use it to make applications on Windows, Mac, or whatever. It's really cross-platform.
So you don't have the cross-platform requirement then if you...
Yeah, exactly.
Right. Right, carry on.
Yes, but which TK Inter does not. Yeah, it's only for desktop use. It's not meaning it's bad. It's quite useful. It's relatively straightforward to make something in TK Inter. But I would say, although Kiwi is like cross-platform, it's not more difficult to use than TK Inter. It's maybe even a little bit easier because you have the separation of the front end with the KV file you program, where you make the UI part of the program, and you have the cleared separation for the backend. In TK Inter, there the developer himself has to be careful about separating both. You should. Maybe not everybody does. In Kiwi, it's straightforward because you have like the front end part, which is the Kiwi design language, and then you have the back end part, which is can be pure Python.
Going back to the use case, maybe now's the time actually to describe a little more on a higher level, so that before we go back to the technical details, so that people know why you chose this approach and what it's good for.
Mm-hmm. So when you want to use mobile, of course you need touch, multi-touch in the best case, which, for example, TK Inter doesn't supply, as far as I know. And of course, you could just write it in Java or like Kotlin. Sure. But there's also as we are working like in the chemical industry, and we have like it's a daughter of Remondis where I'm working. There are several levels of IT over us, so it makes getting stuff relatively complicated. We are allowed to develop in Python, So that was also like a requirement why we came to Kiwi and not like more well-known language in the context of mobile development.
And what does the app actually do in terms of what's the use case behind the app?
It does display like it displays the buildings in the plant. You have like a list of all buildings in the plant, and then in each building there are different counters, and the list of these counters you can press on one building which has a number like 103, building 103. When you click on the building, you get a sub list of all counters or all meters, and then there's, for example, fresh water, steam, pressed air, something like this. And these counters then count some value, for example, cubic meters or power. And in the sublist, then you can go to one of the counters. Then you get like an overview of all the parameters of this counter. And you get a field where you can put in like a value. And you can put in a problem, like a free text field. And this data is then stored in a database. It's SQLite on the phone itself. And then you get an indication that you already have gone to this meter or counter and put in a value. And this is reset after 2 weeks. Normally this is done once a month. So one or two guys are going through the chemical plant and taking in data with this app, and they get an indication. Normally they don't go from top to bottom each meter because the meters are in different levels in the building, and this can also be quite complicated. They have to sometimes to climb up to a meter. And yes, normally you could do this with the digital meters. For electricity, we do this mostly. But especially like water counters and steam counters are very complicated. And it's also quite costly to implement them. And then you have to put in some wires and you have to connect them. And this is normally not done. So it's also kind of cost-saving thing. And the analog ones are normally more robust. That's the reason why we still have these old school counters or meters.
Yeah, because, I mean, the couple of use cases that have crossed my path in similar Internet of Things, and I would reckon this is the use case that you're just describing, are using mesh networks at LoRaWAN and some other IoT technologies to keep it purely digital in order to save this manual approach from even coming into existence, in terms of that somebody has to climb up a ladder, do a manual reading of a meter, and then climb back down again just to enter this into a computer, because A, that's error prone, and B, it's manual, and C, it's not exactly digital, right?
No, it's not. Absolutely right. It's difficult to imagine, but in industrial plants, this is quite common. Of course, nobody talks about this in this way. Yeah?
Well-kept secret.
Who needs the IoT?
It seems a little bit crazy. So we for electricity we have, I think, 99% it's digital counters, and we have a digital system collecting the data, and we do energy management with that. But with the other counters, this is not that easy. Let's say it like this. I mean, and then you have to imagine this is like a building which is from like the 60s. There are machines which are also from the 60s with like big bells, and they are moving, like there's quite a lot of vibration in this parts of the system, then you have to comply with explosion avoidance. Yeah, so they're partly flammable gases. This makes everything much more complicated than it would be in other fields. Then you have the problem with you don't want to, or the customers typically don't want to have a cloud network or something. So the data is not supposed to go out of from the plant side. So normally you have like the coupled system for the inside of the plant, like in intranet in the best case. Sounds like ancient history, and it's kind of is. And in this context, we often develop like small solutions to alleviate part of the problem. For example, when somebody runs around and writes on a paper, and imagine somebody has to read this afterwards and put it in some database. And this we normally try, if it has to be put in handled by hand, we try to make this a one-step thing, and then have everything following digital, if it's not possible to make it directly digital. That makes sense?
Yeah, makes perfect sense. I was going to ask, how did you end up with Kiwi in the first place?
This was like, as I said, we.
And did you look at any alternatives, by the way? Sorry.
I did not. I'm aware that there are more solutions to this problem, but part of our stack is already in Python. We are quite limited what we can download or what we get installed, and this has also problems with Kiwi. In the second step of the process, we can go into if you're interested, because I would say Kiwi is very efficient to program, so it was really easy to get some app running, and the development part was very efficient for us. It was also a reason why we chose Kiwi, and then it's in Python, so it's a language we know well. The problem starts a little bit with Android, and when you, as a developer, develop for like Windows beforehand or for Linux, the file system is so different in Android, and all the write management to write to any storage in the Android system, that made things way more difficult, and building any Android app, you typically need a Linux system or Android Studio, which has also possibility to build things. That made it in the end more complicated than I thought beforehand.
But I think Martin, being the expert when it comes down to IoT and Python on mobile devices, had a question. Martin, why don't you go ahead?
Well, I think we already established IoT is not an option with analog devices. That's
rudimentary.
The reason why I decided to build the app in the first place. Right?
Yeah, we had. There were some ideas. Also, that seems crazy. We'll tell it anyway. There were some ideas to put some cameras in front of the analog counters to record like the counting. It's like the old school power meters. Do you know them with the spinning wheel?
Yeah, of course. Yeah.
Technology about 100 years old or something like this? Yeah. Maybe more?
I'm not quite sure from when this, but they are still quite common in chemical industries. Yeah. But there you have the problem, like when you put a camera there, or there were the idea that the user may make a photo of a counter, and then we extract the data from the photo. But it can be very dirty in such facilities, and this makes things more complicated than one maybe thinks.
Plus the fact that the devices probably would have to sign a GDPR waiver because their data that they emit actually is digitally recorded.
Yeah.
But not to worry about that. I've yet to come across a device that is actually able to sign a GDPR waiver as such.
Yeah. This seems harder than one would guess.
I mean, I reckon the tricky thing comes into play. I mean, GDPR jokes aside now, the tricky thing comes into play basically if you're trying to marry a technology that is almost a century old with this new digital stuff that is just about 10 or 15 years old. And this, as in this newfangled hipster technology, as in mobile and the workflows that comes with it.
Yeah. I can give another example of this where we found like a workable solution for it. So we have like a relatively big cooling tower in our plant. Actually 3 cooling towers, and they were rebuilt about, I think, 2017 or something. And before I started working in this company, the colleague doing the work before did collect a lot of data of these cooling towers. Like, I think it was something like an Excel table with 15 columns and 400,000 data points. I think each point 1 minute, and then over 10 months. And in this data was like temperature of the water, the cool temperature, and then the hot temperature. When the water comes hot from the facility, it's sprayed from the top, runs down, cools down, and is blown with air, and then collects in a pool at the bottom. And there are several input parameters. And for this cooling tower, we made like in the time it was called a digital twin. Today we call it a cooling tower assistant. The idea was to make the regulation of this, the energy efficient regulation of this cooling tower possible. And there we had similar problems. There are big Excel tables which are filled by hand. So there's some data which is collected digitally, but there's a lot of data also people running around and writing down numbers, similar to what I explained before. And the data set was collected out of these data. And then you have to clean this data. You can imagine there's a lot of imaginary things in there, like dates with commas, which makes fun when you want to read it into pandas in Python to analyze it, or people switching the column in the middle. I mean, this is all a sign of this process is maybe not the best way to do it. Anyway, so we had the collected data, and then I did like a machine learning project to try to make a prediction of the cooling water temperature. So what can the cooling tower achieve in the next 8 hours belonging to temperature? The cooling tower is regulated by Solltemperatur. I'm not sure in English.
Say again?
A set temperature. That's the word. So the cooling tower makes water cool. Makes sense? And and then normally the temperature, or in our case, the temperature is set to a certain temperature. For example, 15 degrees centigrade. You want the cooling water to have 15 degrees centigrade, and then the cooling tower tries to regulate on this temperature. Typically, there are some fans pushing up air against the water droplets and cooling the water. Basically, yeah, that's like a cooling tower. You put in hot water at the top, it falls down, and you have some fans which push air against it. The water cools down and is collected in the pool at the bottom and then pumped into the facilities to cool. And the set temperature is like set to 15 degrees, which makes total sense in like in winter or in the spring or in this range. But in summer, normally the temperature you can achieve with a cooling tower is maybe 20 degrees. So then in this phase, the cooling tower is always pulling 100% fan power without actually achieving the temperature. And this was like a setup which ran for several months in this way. And then we had this project where we tried to make it easier for the controllers of the cooling tower to find a good temperature, for example, for the summer or also for the winter time. And in this project, we made like a machine learning project where we used regression to predict the temperature and make a graph to display the expected temperature over the next few days, taking in Deutsches DVD data, so from the German weather. What was it called?
Met Office, essentially. Deutscher Wetterdienst, as in German Met Office, yes.
Yes. And this data you can get for free. And we incorporated this weather data with the regression model, and then we can display it like the achievable temperature with the cooling tower, and then you get some feedback about which temperature you can usefully set, so the cooling tower can actually achieve the temperature you set, and you can also see how efficient that will be. And for this project, as we don't have like live data from the cooling tower, we made the model in such a way that we have as little data as possible put in by the user. In our case, it's only the current pool temperature, so the cold water temperature, which you currently have, and everything else is calculated from the model, which learned over this 10 months of data. And so we don't have we don't have it in the live system, so we don't need to care about the intranet, and we don't need a cloud, and it runs locally, and people can use it without a lot of hassle. That makes sense?
It does indeed. Speaking of the machine learning approach that you used, maybe you can shed, because the reason why I'm mentioning this, I come across all sorts of use cases where actually the Internet of Things, as in IoT projects, are married with machine learning for the very same reasons you just explained, as in predictability as such, and of course saving costs. Maybe now's the time to go into a little bit of detail, actually, what you used in terms of a machine learning framework, whether that was PyTorch or TensorFlow or something like that, and what were the challenges when implementing this, especially with regards to this IoT context?
Mm-hmm. So libraries, we used NumPy, Pandas, and scikit-learn. I know scikit-learn is not like very advanced, or it's more like a collection of stuff that works in the machine learning context. I would describe it in this way.
So you didn't use any of the neural network simulations like PyTorch or TensorFlow? Okay, interesting.
No, I didn't. Yeah.
Wow. Do explain.
Are you aware of scikit-learn?
Yes, I am. Not sure about Martin though, but not sure more about this.
So I actually didn't prepare for scikit-learn, but generally it's a Python library where you can use like a well-established machine learning algorithm, and you can also use like linear regression. And so all the basic stuff to do a regression you will find in scikit-learn. And it's relatively easy to set up like a notebook, a Jupyter notebook, where you can load scikit-learn, pandas, and NumPy maybe, and just test your historical data, like the 10 minutes of the cooling tower I had, on different algorithms or different machine learning approaches to fit the data and see how well the data is fitted with the model you choose. And for example, I tested like multivariable linear regression, random forest, some neural network I forgot. And so I tested several approaches in parallel with historic data and tried to predict like always 8 hours in advance. And then I looked at the distribution of error. When you have like systems which are like tree-based or like a random forest, you can sometimes have that non-defined values get you, or data which is not in the training data can lead to relatively high peaks in output. And when you have a regulation system, you don't want to have peaks like this. You want to have a relatively smooth curve of reaction to changes in parameters.
Yeah, the reason actually why I mentioned these neural network simulations like PyTorch and TensorFlow, essentially for the two listeners who have been sleeping under rocks for the last 2.5 years maybe, TensorFlow and PyTorch are very popular frameworks for essentially simulating a very simple, let's put it this way, brain-like function. Essentially what they do, and Keras being the domain-specific network on top of TensorFlow, is aimed at actually image recognition. But at the very core, what they do is actually they spot patterns. So you have two phases essentially where you train the neural network. This is called the training phase, aptly. And then you have the inference phase, basically, where you put this whole thing into production. So you train, for example, Keras with a set of images and tell them, sorry, this is not a human, this is not a laptop, but this is a mobile phone you're looking at right now. And then during the inference phase, essentially, you put a couple of images in front of the likes of Keras, and they tell you within a certain probability spectrum that the image they think is a mobile phone, laptop, or human being, or that sort of thing. But what Tobias just explained is slightly different because this is not a neural network approach as such. Tobias, when you mentioned a neural network using scikit-learn, you simulated this on top of the library, right?
So, the scikit-learn library contains like ready-built models with good default values. Typically, when you train a model, you need some set parameters, and like the learning rate, for example. So how fast does the model update with each data point you add? And scikit-learn has big libraries of these different approaches, like random forest and linear regression or something. And they typically contain well-established model approaches, and they typically come with useful default parameters. And it's much more limited. Like in TensorFlow, you can program absolutely new approaches, and it's relatively fast and stuff. But scikit-learn is more like you want to have image recognition, and you don't want to put in a lot of development time. Then you get like a well-established, good working model, and then you can, with a few lines of code, build like a model which, for example, sees like edges on images, or make a regression model like I did.
Interesting. Yeah. Did you consider any sort of Bayesian inference? Because that's another kind of popular approach to machine learning on a more statistical level. I
did not. In the time I did this, I wasn't aware of Bayesian.
Okay.
But so I have to say, I didn't study this. This was like
fair enough.
Yeah. and then I looked some tutorials and yeah.
I mean,
I was
scikit-learn
just going to say the scikit-learn is more the supervised learning side, right? It's as opposed to your PyTorches and TensorFlow stuff like that, which is why you've got your regressions and things like that in scikit-learn.
I mean, yeah. I always had the impression that scikit-learn is more for like people who want to apply stuff.
users rather than developers.
Yeah, kind of. And I think TensorFlow and what was the other again?
PyTorch.
I mean, PyTorch now is like so common, and all the big labs used it for like ChatGPT and co. So it got quite established, but it's also more what comes from the research side. And I think scikit-learn.
Both frameworks do, yes.
Yeah, that's true. But I think scikit-learn is more like, also if you do a PhD and you want to make a simple model, it's typically want to use a well-established simple model, then it's typically easier to do in scikit-learn.
Scikit-learn is the way to go, yes. Because PyTorch and TensorFlow, what they actually do is, and this is the reason why they're pretty good at, are pretty much generic approaches to simulating a neural network. For example, Keras is actually a collection of, and sorry, I'm digressing now, but it's probably worth kind of going a little bit into detail here, because both approaches allow you to model certain sets of layers of neural networks, which you then can combine to achieve a certain domain-specific approach. As I said, for example, Keras is pretty good at image detection. So the way it works basically is Keras takes a look at an image, and I'm simplifying things now greatly. Keras takes a look at a certain image and does a certain sort of simplification followed by a phase called feature extraction, and then it comes to an educated guess what this really is. So, for example, if Keras is looking at a face, it can do away with the fact that we're looking at a Caucasian face, that we're looking at a Native American face and all the rest of it, but faces do have two eyes. Faces do normally have a nose, and next to the faces are things called ears. And normally faces are covered with hair. If you're not looking at a shaved head, that is. But jokes aside now, this is basically how the likes of Keras come to the conclusion that yes, with a probability of, say, anything between 70 and 80%, we are looking at a human face now. And that's exactly how these neural network simulations and domain-specific frameworks, like Keras is on top of TensorFlow, work. So it's essentially a much more generic / comprehensive approach at machine learning in terms of how to model neural networks, doing the things you want to have them to do.
I think if you want to develop new approaches in machine learning, then of course, and then this is the way to go. There you wouldn't go with scikit-learn, for example, because it's more like a toolbox. Scikit-learn is more like a toolbox. We used well-established tools, and when you want to build a new tool, you wouldn't use scikit-learn. These image models are normally also pre-trained. You normally don't start by 0. You normally take a pre-trained neural network and then train it for your application. Is that right?
Exactly, because Keras comes with, or you can get, a lot of pre-trained models on top of Keras that allow you to do image detection on top of the things that Keras as a domain-specific framework already brings along. Changing tack just a little bit, and before we wrap this up, what would you say are or were the biggest challenges implementing this overall approach from the likes of media breaks right up to this machine learning approach that you implemented? If you can speak to this.
Sure. I think the biggest problem in the industry I'm in is typically to get data. So we typically do maintenance in the companies, for the companies, but at this specific cooling tower, we do control. So there we have data directly available and we can use it. But when we want to do anything which is in a company we work for, it's very difficult to get data at all. There's a lot of handwritten data, which is very hard to read in a machine learning model. There's a lot of cleanup work. I think this is the biggest part of the project. Like training a model and testing models, which work well, this takes maybe a day or two. With scikit-learn at least. It's very straightforward. But getting clean data or cleaning data up is quite a lot of work, and getting people to give you data. This is also a big problem.
Yeah, it's the age-old problem in the data science, isn't it?
Yeah, and the last thing is maybe deploying it. We chose a very easy, low requirements way to implement it. I think often these machine learning projects die because you don't get access to data for the inference time, and this we avoided by making it very simple and using as little data as we could. As a last word to that.
Excellent. And with that, I think it's time for the boxes. Tobias, what's your pick of the week?
I'm curious. Did anybody ever put in Harry Potter and the Methods of Rationality?
Can't recall, Martin.
No, I can't. I don't think so, actually. No.
Not even your daughter didn't know.
I mean, it's not new. It's like 2011, I think. I'm not quite sure. It's written by a scientist. It's a fanfic of Harry Potter, and it's Harry Potter has grown up by an Oxford professor. Petunia married an Oxford professor, so it's a parallel universe story. And
okay.
Harry learned science, and it's like a nerd, like a hard nerd. And then he gets a letter from Hogwarts and asks, what? What's going on? And then he tries to understand magic from J.K. Rowling scientifically, which is hilarious.
Details, of course, will in the show notes. Martin, over to you. What's your POC?
My POC is something called Slow Horses, which is a TV series, and it has some very good actors in it, and a good story as well. So, yeah, well worth watching. The likes of Kristen Scott Thomas, Gary Oldman, people like that. So
this was the rage in the 80s, if I recall correctly, right?
What is?
Slow Horses.
No, this is a new one.
Contemporary?
Yeah.
I watched this in Ireland in the 90s, and it was classified as a rerun.
No, I think this was made in 2022, so you're probably thinking of something else.
I see. It's about some British society shenanigans, no?
It is, yes. Yeah.
So, okay. So the time machine does work. Excellent. Martin, good to know. Of course, details will be in the show notes. If the archives play along, of course.
Are they fixed? Or are they still being DDoSed? Yeah.
Okay. My POC is actually the old school French cuisine. I tried a couple of dishes again.
Like frog legs and stuff.
No. Like kind of 200 years old. For example, I had a bœuf bourguignon the last weekend. That was done to perfection by a recipe. I reckon. I mean, we didn't check out the paper quality, but I reckon the cookbook alone was about 100 years old. So I reckon the recipe goes way back further. And it took us about 5 hours to cook the whole thing. but the quality was just amazing. And I tried a couple of similar dishes over the last couple of weeks, and this made me really curious, basically, to go to a couple of graveyards, so French ones, of course, and dig up these old recipe books. I'm joking, of course.
They meant to dig up some old corpses.
No. There must be a trove of long-forgotten French old-school recipes, as in how the people 150 years cooked in France, and probably it has, with this kind of nouvelle cuisine range and all the rest of it, never mind the more modern approaches to French cuisine, has long been forgotten, but it's just waiting to be dug up again. So stay tuned. Sorry, say again, Tobias?
Where did you find the recipe?
The recipe was actually, as I said, in a book about 100 years old. We came across this by accident, but given the fact that the preface of the book spoke about ancient recipes being in the book, I reckon that the recipes are at least 200 years old. Needless to say, it's a well-guarded secret, so I can't reveal any links or whatever, because the book is long out of print anyway. But I'm sure that with a proper search engine, you will come across these recipes too, if they are in the public domain.
They should be, huh? I mean,
Indeed. Let's see. And with that, Tobias, thank you very much for the insights. Much appreciated.
Yeah, thank you very much, Tobias.
Thank you for your time.
And speak to you soon. This is the Linux In-Laws.
You come for the knowledge,
but stay for the madness.
Thank you for listening.
We hope you liked this feature presentation. If so, please spread the word. If not, please let us know. Feedback at linuxinlaws.eu.